Okay, so now we're up to sort of the last part of the lecture. So this time we're going to be talking about inverses. So when you do inverses, it's a good idea to follow the specific process. So there's like a very straightforward process to use. And when you follow it, you're guaranteed to get the marks. So let's say you've got y equals f of x. If you're given x, then you can easily find y. So you can easily find y equals f of x. So if you're given y equals f of x, which equals 2x plus 3, and x equals 2, you can say f of 2 equals 2 to the power of 2 plus 3, which equals 3, which equals 4 plus 3, which equals 7. What about the other way around? So if you get a y, can you find the x? So that's the point of the inverse function. So it's basically to reverse the original function and sort of invert or swap x and y. A key condition is the function has to be one-to-one. So we're coming back to the vertical line test. So what it means for a function to be one-to-one is I'll draw a horizontal line, it should only intersect once. I draw a vertical line, should only intersect once at any point. So here, this function isn't one-to-one. So here, vertical line intersects once, but horizontal line actually intersects twice. So it's not a one-to-one function, and that's where we get issues. So we need to restrict the domain to make it one-to-one. So for example, let's do the quadratic again. Got y, got x. Let's restrict the domain. So this is, perfect graph. 0, 0. So this is one-to-one. Because if I draw a vertical line, intersects once, horizontal line intersects once. So my point is that if you have a function that's not one-to-one, you can always restrict the domain and make it and force it to be one-to-one. Okay. So a few key properties of inverse functions. So firstly, f and f inverse. So they're related by a reflection about y equals x. So let's say you've got, let me illustrate that. So y got x. Let's say this is our original function. This is the line y equals x. The inverse function will look like this. So it's reflected. And they also intersect along that line. So they intersect only along that line. And the domain and range swap. So this is a really useful property. So the domain of the original function becomes the range of the inverse function. And the range of the original function becomes the domain of the inverse function. So that's because you're swapping x and y, so you're also swapping the values of x and y. So the steps to do it, first, you have to write y equals f of x, or let y equals f of x. Swap x and y, so you have to say to find inverse, swap x and y, and then rearrange to make y the subject again. And then I should write a number 4, write f of 1 of x equals, and write it. So don't just leave it as y equals something in terms of x. Oops. Oh, let's not go there. So find the rule for the function. So let's actually find the rule for the inverse. So let's say h of x equals 2x cubed plus 1. Find the rule. So it's just asking for the rule. It's only 2 marks. So we don't need to give the domain or anything. Find the rule for the inverse function h inverse. So let's do it. So first I'm going to do let y equals 2x cubed plus 1. Or which equals h of x. Or you can say let y equals h of x. You don't need to even write all of that out. Next, to find inverse. So I can write out inverse, or to find h inverse. Actually, I won't write that. I think it's better to just write to find inverse. So to find inverse, swap x and y. Okay, so that will help us find the inverse. So therefore, x equals 2y cubed plus 1. 2y cubed equals x minus 1. Y cubed equals half of x minus 1. And then go other side. Y equals half of x minus 1 to power of a third. So that's 1 on cube root of 2 x minus 1 to the power of a third. So I can write it like that. Okay, but we're not done yet because we want to find the inverse function h inverse. So we can't just leave it as y equals. We have to say h inverse of x equals 1 on cube root of 2 x minus 1 to the power of a third. And that's how we find the inverse function. So let's see the marking. So just over half the people got this correct. And you can see that it's not too hard to get those marks though. Okay, so let y equals 2x cubed minus 1, we've done that. For inverse swap x and y, we've done that. Make y the subject like this. Yeah, we've done that. So we've gotten all those marks. And the guide itself says, the report itself says that you're not supposed to proceed directly from this to this. So you can't just go directly. You need that for inverse swap in x and y. Okay. A common error. So this is a common error. And obviously, we can't write it like this. So we have to have your function in terms of x. So you can't write h inverse of x is something in terms of y. Not going to work out. Okay, so that's basically the process of finding inverses, and it's pretty much the same for every graph. Let's do another example. So this is from a VK exam, exam 2 from 2014. You've got a function, okay, they've given this is the graph. So they don't give the graph, but it's a good idea for you to draw the graph yourself. It's just more convenient. And it will have an inverse function for what values of d. Okay, so basically what domain will give an inverse function for this. So what you have to do here is you have to see when the function is 1-to-1. So you have 3 scenarios. So first scenario, from here to here, a 1-to-1 function can exist. So you've got d equals negative infinity to negative 4. We can include 4. Our second scenario is maybe from here to here. So here d equals, so include 7 to infinity. So here again, it's a 1-to-1 function. And lastly, you can have this middle part. Here, d equals negative 4 to 7 included, and that's it. Okay, so the reason that I'm splitting the graph like this is because it will only have an inverse function if it's 1-to-1. So remember 1-to-1, when you draw a vertical line, should only intersect once. When you draw a horizontal line, should only intersect once. So that's the point of a 1-to-1 function. Okay, so it'll have an inverse function for, let's see which of the values correspond. So negative infinity to negative 4. No, that's nowhere. Okay, fine. Negative 4 to 7. That's nowhere. Okay, we can't do that. Next, 7 to infinity. Yep, this will work out. Perfect. So even if it doesn't include that 7, it's still, like, this is still a subset of this domain. So it still works out for us now. So the answer here is B. And only 55% got it right. So you can see that it's not important not only to, I guess, memorize the concept, but to actually understand it and apply it. Okay, so let's do another question. So let f be all reals except 0. Okay, f of x, okay. Find the inverse function. So remember what I said toward the start. find f inverse. So it's not saying find the rule of. So look at the difference between this rule and this one. So here it's asking you to find the rule, but the wording here is different. Find the inverse function. So here you're going to have to include the domain. And you can see the marking, there's also more marks here too. So it makes sense. Okay, so let's do it. Same process as before. Here, pause, have a go at the question, and then listen to the recording again. So let's do it. So we've got f of x is 3 on x minus 4. So let y equals f of x. Okay, let y equals f of x, therefore y equals 3 on x minus 4. To find inverse, swap x and y. So therefore 3 on y minus 4 equals x. So we've just swapped x and y. Now let's do 3 on y equals x plus 4. Y equals 3 on x plus 4. Okay, perfect. And now we can't just leave it like that. We need to find f inverse of x equals 3 on x plus 4. Okay, that's all well and good, but it's asking find the inverse function of f. Remember, the domain of the inverse equals the range of the original function. And the range of the original function is from negative, oh wait, not this, all of your numbers except negative 4. Okay, so drawing on our knowledge of hyperbolas, we can say the range of this function is all real numbers except negative 4, because the asymptote is at y equals negative 4. So therefore, the domain of the original function equals all reals except negative 4. Now, you'd probably get the marks if you leave it like that, but just to be safe, let's put it all together. So let's find it. Let's actually find the function. So let's define it. Oops, not like this. F inverse, define it. The domain is all reals except negative 4. Codomain is R, always R for methods. And then F inverse x equals 3 on x plus 4. And that will get us the marks that we want. So let's have a look at, I don't have the solution for this. Okay, you can always check out the VCA website to find who got it right. Okay. Oh, actually, here. Only 30% got it right. A few students realized that the rule and domain need to be specified. And the definition of f should be provided. Okay, so basically what's happening is a lot of people lost marks because they didn't give the domain. That's what it's saying. So you can see that it's pretty easy to get full marks. You just need to be very wary of the questions they're asking you. Okay, so a few things to remember. When we find the inverse functions, they're reflected on the line y equals x. So that will help you think about how the graph might look. And we can also say we swap the values of x and y. So basically, if they already give you a graph and it's asking you to just draw the inverse function, you don't need to do all this algebra. You can just visually try to do it by reflecting it on the line y equals x. Or if you're given the equation, you can always use algebra to swap x and y like we've been doing so far. So domain and range swap over. Because we're swapping the x and y, we also swap the domain and range. So that definitely makes sense because just logically, when we swap x and y, we swap the domain and range. So essentially, if you have the point A, B on the original graph, so the original function, then the inverse, it will be swapped, the x and y swapped, and it will actually be BA. And another key thing that people forget, so f of f inverse of x is just x. So let's have a go at this one. Okay, so first part, find g of x. G of x equals f of x. Okay, doesn't matter. So g of x equals f of 1 on x squared. So f of x is basically where there is an x, we're putting the whole function in. That is 1 on x squared, which equals 1 on x to the power 4. That's equal to x to the power 4. Okay, perfect. And remember, domain is all positive real numbers. Evaluate g inverse of 16, where g inverse is the inverse function of g. So I'm assuming this is an exam 2 question because it's only 1 mark. Okay, g inverse of x. So first, let y equals g of x. Therefore, y equals x to the power 4. Swap. Oops. Okay, swap x and y for inverse. Therefore, y to the power 4 equals x. Y equals the 4th root x. Okay, so this is positive. So this graph would look something like all positive real numbers, x squared, like something like this. So the range of this is not including 0 to infinity. Okay, so here we can say g inverse of x equals, oh, we don't even need the domain actually. I don't know why I did that. Okay, g inverse of x is 4th root of x. Therefore, g inverse of 16 equals 4th root of 16 is 2. And it's positive value because it's the positive domain. So hopefully that makes sense so far. Keep going. Again, reiterating what we've done so far. So inverse functions are reflected along the line y equals x. If you have an intersection between the original and inverse, it's going to occur on the line y equals x. So instead of going f of x equals f inverse of x to find the intersection, you can just do f of x equals x for the intersection. So it's just a shortcut to make your life a lot easier. So that's why you can just do f of x equals x or f inverse of x equals x, whichever one is easier. So that will keep it really clean, won't make it messy or anything. So let's do another question. So we've got a cubic function defined by this. Write the expression for the inverse. Okay, beautiful. Write an expression. So it's just a rule. Okay, so let y equals 3 minus 2x cubed to find inverse. So to find inverse, swap x and y. So when you swap x and y, you've got 3 minus 2y cubed equals x, minus 2y cubed equals x minus 3, y cubed equals x minus 3 on negative 2, y equals cube root of x minus 3 on negative 2. Okay, so therefore expression for q inverse of x equals cube root of x minus 3 on negative 2. And that's how we would solve this one. So here we go. Yeah. Okay. Beautiful. Yeah. So we've done it correctly here. A lot of people got it right, which is great. It means that, it was a relatively easy question. Here are some of the few errors as well. So the examiner report, the exam report is actually a really good resource, because when you do an exam and you're correcting it, it's actually telling you what to look out for, or the common mistakes that are made that you should try not to make in the future. Okay, next, the points of intersection between the graphs q of x and q inverse of x. Okay, so what was q of x? Q of x, 3 minus 2x cubed. So q of x was 3 minus x cubed. The points of intersection. So to do this, it's actually easier to go 3 minus 2x cubed equals x. Solve. So 2x cubed plus x plus 3 equals 0. You can solve using your calculator, because I'm pretty sure this is going to be a calculator question. And you should get 1, so x equals 1, so the 0.11. And only 60% got it right. So it's likely that it might have been some sort of a calculation error, or they might have complicated it by going, by equating these two instead of just equating one of them to x. Okay, so we're almost at the end of the lecture. Let's see what the time is. Okay. Okay, so the graph of this function with the rule y equals g of x is shown below. It's a one-to-one function. Which of the following is most likely to be the graph of the inverse function? Okay, so this is a very, very common type of question. So what I like to do is I like to sort of outline y equals x. So it's a bit of a guide for me to figure out how the inverse function will look. Okay, and then it reflects. Okay, there's one. Reflects along the line, something like that. Okay, so let's see which one looks the most familiar. D, definitely out of the question, because this is reflected, so it's supposed to be here like that, and here, this is out of the question. This is definitely out of the question. Why is there a straight line on top? See, it's not going to work. So it's either A or B. So with A, it's looking really good. It's looking like what we want. With B, the only issue is this point here. It's supposed to be like this. So that's why A is the correct answer. So we've eliminated all of our options and we've narrowed it down to make A the correct answer.